Hello, my dear mechanical and civil students. How are you all? What's up? कैसे हैं सब लोग? Please, guys, do join me fast. And more than that, please do let me know through the comment section. Mark your presence by writing in the comment box. Am I audible and visible to all of you? Please respond through the comment section so that we can start our session on time. This is Chandrasekhar welcoming you all to the India's largest, the best, and your favorite live learning platform, that is BYJU'S Exam Prep. And today we will be having the conceptual clarity about the hydrostatic force, the force which is exerted by the pressure of the static fluid, and the concept of buoyancy and flotation. Please, guys, do join me fast and keep on responding through the comment section. Am I audible and visible to everyone? Ranbir, good evening. Have you asked your civil friends also to be part of this session? This fluid mechanics is common for mechanical as well as civil aspirants. So definitely, I will be very happy to see here the civil students as well. You guys are watching me live through this series which is running on BYJU'S YouTube channel every day at 8 p.m. Not every day, but every alternate day at 8 p.m. That is Mastering Concepts for GATE 2023. Here we are providing you the sessions for concept clarity as well as we are giving you the sessions for numerical practice, as well as there will be a live quiz at the end of this subject, that is the fluid mechanics. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Wanakam. Once again, I welcome you all to this beautiful session and important session for your GATE 2023 examination. How many of you are preparing for GATE 2023 examination? Anyone here who is preparing for 24 or 25? Please do let me know. Everyone, I cannot see your comments. Only Ranbir had talked to me. I want everyone to keep communicating with me, keep asking me your doubts as well as keep sharing your knowledge. Then the class will become more lively and you will enjoy the concept with the best or the most simple manner. Okay, Bhavya, 23. Good. Good evening, Mithun. Welcome. Some of the students are very regular, very religiously following this series. I hope they are getting the most benefit out of this free series which is running on BYJU'S Exam Prep. And this is my entire schedule of fluid mechanics. Those who have missed the previous sessions, you can search these sessions on YouTube and do watch the sessions. You will definitely fall in love with the subject. That is my promise to each one of you. Prem Chandu, are you from mechanical or civil? The weightage is around 8% to 10%. In the first lecture, I had discussed about the weightage of the subject in GATE 23, but it is around 8 to 10%. But the important point is that the fluid mechanics is one of the core subject of mechanical as well as civil engineering, and that is the prerequisite of many other subjects. So that is why the subject become more important. Moreover, because it is having unlimited practical applications, so the subject is going to be important for interview point of view as well. But my point, Prem Chandu, mechanical civil ke bacche chahiye. Anyone civil, please make some noise. Anyone here from civil branch? Hi Susaban, good evening, welcome to the session. So the classes are running on Monday, Wednesday, Friday and Sunday, and we will be having Menti session quiz, live quiz on 29th of this month. That will be the end of this fluid mechanics, and then the next subject will be going to be started. All right. Now what we are going to discuss in today's session, let us have a look to that as well. First of all, we will be talking about the hydrostatic force acting on the plane surface, and we will be talking about three orientation of the plane surface. The plane surface, is kept in inclined position, how much will be the pressure force and where it will be acting. The plane surface is kept in vertical position, and then we will talk about the hydrostatic force on the plane surface, which will be kept in the horizontal position. And next we will be talking about the hydrostatic force on a curved surface. So on a curved surface, what we need to do, we need to resolve the force is in two components. One is horizontal and another is vertical, and from this horizontal and vertical component we will develop the net or the resultant amount of hydrostatic force exerted on a curved surface. Then we will enter into the concept of buoyancy, how the buoyant force is defined, what is the physical significance, where does it act, what are the parameters which are affecting the buoyant force. Everything about the buoyant force will be discussed, and along with that the Archimedes principle we will be going to discuss next. And after that we will be talking about the various conditions for equilibrium of for a submerged body like a submarine, as well as the floating body like a ship. What should be the ideal condition for equilibrium for the submerged as well as the floating body? That will end our discussion for the day. All right, so shall we start? As always, I ask you very simple question before we start our session. There is a question on the screen. Can you just let me know the answer to this one? What does that point called about which the body oscillates when it is disturbed? And please do like the session so it reaches to maximum number of audience, civil as well as mechanical engineers. So do not forget to like the session. That is my humble request. इतना तो आप कर ही सकते हैं. It is not chargeable. It is completely free to like the session. And if you do not like it, you can unlike the session as well. So I am waiting for your response. And meanwhile, let me quickly introduce myself. Most of the students already know about me. My name is Chandrasekhar. Naam to suna hi hoga. I am mechanical engineering graduate from IIT Delhi, and from last 9+ years, I'm completely into teaching, guiding the students who are preparing for various competitive examinations like GATE, engineering services, and other PSUs. With my knowledge, my qualification, my experience, I will try my level best to make you understand the concept of fluid mechanics in the most simple, most interesting manner, provided you should be with me throughout the session with your full dedication, with your full enthusiasm, and with your full energy. Are you all ready? Yes. It is called as Meta Center. Yes, Baru, Anil, Ranbir, Susovan, Mithun, Bhavya. Well done, guys. Well done. Keep on talking to me. Keep on discussing your doubts through the comment section, and you can contact me through the mail ID which is there on the screen, as well as you can join me on the Telegram also to have the better communication, to have the better discussion about your doubts. You can be part of my Telegram group. So many students are already there on my Telegram group. The link is there on the screen. All right, without wasting much time, let us start. But if you are interested to be part of our paid courses, you can join us. So many students through our paid courses have secured all India rank in a single digit with our guidance and their hard work. You can also achieve your dreams. So you can join our paid courses as well. And if you are not in a position to join the paid courses, you can join our free classes which we take from time to time. But for that you need to subscribe our YouTube channel so that the notification, all the updates of our free sessions will be coming to you. All right, shall we start? Ready? Keep your pen and notebook handy. Keep on writing whatever the important points you feel like. Do write the important points in your notebook so that you will not forget them and you will be able to apply those concepts in your questions. All right, so how is the Josh? Please make some noise so that we can start our session. Shall we? क्या इतना एंथू नहीं है? क्या हुआ? Are you tired? Am I audible and visible to all of you? So let us start talking about the hydrostatic force. That is nothing but the pressure force exerted by the static fluid on a plane surface. As you all know that the pressure linearly increases with depth. The pressure always increases linearly with depth in a static liquid according to hydrostatic law. So that is why we cannot directly calculate the pressure force. Pressure into area will not give you the hydrostatic force. We need to go for the integration. Getting my point? If there is a free surface, let us say, and there is a plane surface kept like this. So because the pressure is variable, as the pressure is variable with depth, linearly varies with depth. So what we need to do, we need to take a small element dA, and then we will find out the hydrostatic force by integrating this pressure at this location into dA. That will give you the answer, and the limit will be from point x to point y. X to y. If you do the calculation, then you will be getting rho into g into a into x bar. That is the formula for the hydrostatic force acting on the plane surface. If you can see, whether the surface is inclined, vertical or horizontal, you will be getting the same expression for the hydrostatic force. Can you just let me know what is rho here? What is rho here? Who will tell me what is rho? Rho is the density of the fluid. What is rho here? Rho is the density of the fluid. What is g? G is the acceleration due to gravity. The value is 9.81. What is a? Who will tell me the value, the significance of this a? What is a here? What is a? Yes, Bhavya. Rho is the density. What is a? And what is x bar? X bar is the depth of centroid of the plane surface from the free surface. Different authors use different notations. I am using x bar for depth of centroid of the plane surface from the free surface. What is A here? No, A is not the projected area, Bhairu. That is what you need to understand. The most important thing is understanding the concept of A. X bar is, for an example, this is the surface. Let us say this is the surface, plane surface. It can be kept vertical, it can be kept inclined, or it can be kept horizontal. So there must be a centroid of the plane surface. There must be a centroid of the plane surface, even if it is kept vertical, inclined, or horizontal. There must be a centroid. Centroid is the point where I am holding this surface. Now, x bar is the depth of the centroid from the free surface of the liquid. Depth of the centroid of the plane surface. Even if it is inclined, then x bar will be the depth of the centroid of the plane surface from the free surface of the liquid. That is the vertical distance. That is the vertical dimension, vertical measurement from the free surface. And A is the, yes, depth of the centroid from the free surface. A is the area, listen very carefully, very, very important. A is the area of the plane surface in contact with the fluid. What is A here? A is the area of the plane surface in contact with the fluid. The area which is not in contact with the fluid will not be taken into consideration. A stands for the area of the plane surface which is in contact with the fluid. For an example, if I take an example, there is a plane surface, let us say. There is a plane surface of having a dimension 5 meter by 5 meter. It is a square plate. Square plate 5 meter by 5 meter. If the liquid is at 1 meter below the top edge of the plane surface, this is the level of the liquid or water level. The water level is 1 meter below the top edge. Then can you just let me know what will be the area? In that case, what will be the value of area and what will be the value of x bar? If you are able to write area correctly, x bar correctly, rho correctly, then you will get the correct value of the hydrostatic force which is acting on the plane surface. Have you understood it? 5 meter by 5 meter. And the the free surface of the liquid is 1 meter below the top edge, then what will be the value of area? What will be the value of X bar? And after calculating the amount of hydrostatic force, you will get the unit as Newton when you will put all the parameters in their SI unit. And then what we can do is, we can find out the location where the hydrostatic force is supposed to be acting. The hydrostatic force F is supposed to be acting at center of pressure, and the location of the center of pressure will be lying below the centroid of the plane surface. I am calling this to be H. The depth of center of pressure where the hydrostatic force is supposed to be acting is lying below the centroid of the plane surface, because the pressure is increasing with depth. So H is greater than X bar. Are you getting it? No. The value of area will be 5 into 4. Area will be 5 into 4. This is 5 and this is 4. 5 into 4, Varun. It will be 5 into 4, and do not consider this region. Only you need to take the centroid of this surface only. The centroid is, because this height is 4 meter, the centroid is at a depth 2 meter from the free surface. So the value of X bar will be 2 meter and the area will be 5 into 4. Is this clear to everyone? Yes, Baru, correct. Is this clear? Now we need to find out the location of center of pressure or the depth of center of pressure from the free surface. For the inclined surface, theta is the angle of, what is theta here? Theta is the angle of inclined surface with the horizontal. Inclined surface with the horizontal. Theta is the angle of inclined surface with the horizontal. If the inclined surface is like this, so if this is the inclined surface, so we need to take the angle with the horizontal. This will be considered as theta. Theta is the angle of inclined surface with the horizontal, and A is the area of the plane surface in contact with the fluid. X bar you already know. That is the formula we are getting for the inclined plane surface, which is having the angle of inclination as theta. For the vertical surface, what is the value of theta? Can you just let me know for the vertical surface what will be the value of theta? If the surface is vertical, what will be the value of theta? Theta is the angle with the horizontal. Angle with the horizontal, what is the value of theta? Do you agree theta will be equal to 90 degree? Theta will be 90 degree for the vertical surface, and if theta is 90 degrees, sine 90 will be equal to 1, and that is why the expression will become X bar plus Ig by A X bar only. If it is horizontal surface, then theta will be equal to 0 degree. Do you agree? For a horizontal surface, theta will be 0 degree and sine 0 will be equal to 0. That is why the second term will get vanished from the expression. Is this all clear to everyone? That is one approach. Another approach is to find out the hydrostatic force. What you can do is you can calculate the average pressure, because the pressure is variable. That is why we need to go for integration. If we can find out the average pressure multiplied by the area, will also give you the same result. But what is the average pressure? How to calculate the average pressure? Average pressure is the pressure which is developed at G, centroid of the plane surface. The average pressure is the amount of pressure which is developed at the centroid G. The average pressure is the pressure which is developed at centroid G. What is the value of pressure at this location? The pressure at the top is equal to 0. The pressure linearly increases with depth, and the depth is X bar. So do you agree the average pressure is equal to rho of fluid into G into X bar multiplied by the area will give you the same expression, that is rho G A X bar. Hi Rajesh, good evening, welcome. Is this clear to everyone? Is this all clear to everyone? That is one approach. By using the formula or by calculating the average pressure multiplied by area will give you the result, and you can find out the depth of center of pressure which is lying below the center of gravity or the centroid of the plane surface by using the formula, that is x bar plus Ig by Ax bar sine square theta. What is Ig here? That is also important. What is Ig? Ig is the area moment of inertia of the plane surface, whether it is horizontal, vertical or inclined, it does not matter. It is the area moment of inertia of the plane surface about its centroidal axis parallel to the base. About the centroidal axis which is parallel to the base. What does that mean? Look, if this is our plane surface, this is the centroid. This is the centroid and the centroidal axis is the axis passing through the centroid and which is parallel to the base. This is the base. So this is the axis about which we need to take the moment of inertia. Have you understood it? If the surface is kept like this, then this will be the axis about which we need to take the moment of inertia. The axis which is passing through the centroid and the parallel to the base of the surface. Even if it is inclined like this, then we need to take the axis which is like this. This is the axis about which we need to take the moment of inertia, that is Ig. For a rectangular surface, if the rectangular is kept like this is L, this is B. Then if we want to take the moment of inertia or Ig, what is the value of Ig? This is Ig will be equal to L into B cube by 12, isn't it? And if the surface is kept like this, this is B and this is L. Then how to calculate Ig? This is the centroid and the moment of inertia about the centroidal axis. This is Ig. Here it will be B into L cube by 12. Parallel to the base. हाँ, जैसा रखा जाए, well, that is the base. If it is kept like this, then this is the base. If it is kept like this, then this is the base. Yes, it will be mentioned how the surface is kept. And for a triangle, whether the triangle is like this is the height is h and base is b, or the triangle is like this is b, this is h, or the triangle is like this is b and the height is h. So the moment of inertia about the centroidal axis, we need to find out the centroid. And the axis which is passing through the centroid. So for a triangular figure, Ig will be equal to B into h cube by 36. And if it is a circular, if the surface is a circular plate, then G is here, the diameter is let us say D, then you should memorize this. Ig for a circular figure will be pi by 64 d to the power 4. These are some of the standard figures for which you need to memorize the value of Ig. I hope it is clear. So that is one approach, by using the formula. If you are very much relying on the formula, then use the formula to find out the amount of hydrostatic force as well as the point of application, that is called as center of pressure. There is another approach. Have you heard this approach? Pressure prism or pressure diagram. Have you heard about the pressure diagram? That is the another approach to calculate the hydrostatic force and the point of application. For an example, this is our vertical plane surface, and the free surface of the liquid is coinciding with the free surface. With the top edge. The free surface of the liquid is coinciding with the top edge. This is the liquid line. This is the free surface of the liquid. And the density of the liquid is, let us say, rho. Rho is the density of the liquid. This is the arrangement. There is a vertical plane surface. And the free surface of the liquid is coinciding with the top edge. The pressure at the top. What is the value of pressure at the top? Yes, Susoban. Or you can convert multiple fluid into single fluid also. That also you can do. So the pressure at the top is equal to 0. We are talking about the gauge pressure. The dimension of the surface is B by H. The dimension of the surface is B by H. The B is the width of the plane surface and H is the height of the plane surface. Then we need to draw the pressure prism. The pressure at the top is 0. Pressure linearly increases with depth. Pressure is increasing linearly with depth. So the pressure at the bottom will be rho into G into H, isn't it? So the pressure force will always be normal and compressive. So this is how the pressure diagram will look like. This is how the pressure diagram will look like. It will be a triangle. Pressure diagram will be a triangle, isn't it? It will be a triangle. The pressure at the top is 0. The pressure keeps on increasing with depth. The pressure keeps on increasing linearly with depth. So the pressure diagram will be something like this. The pressure prism will be like this. This is the pressure prism. This is the vertical surface and the pressure force can be shown like this, like a triangle, like this. So how to calculate the hydrostatic force? The hydrostatic force is given by volume of the pressure prism. It is a three-dimensional figure. The volume of the pressure prism. How to calculate the volume? Volume of this triangle. This is the pressure prism. Can you see it? This is how the pressure prism will look like. So we can find out the area of this triangle and the width multiplied by the width. That will give you the volume. That will give you the volume. If I try to show you like this. This is the three-dimensional figure. This is the pressure prism. So we can have the volume of this pressure prism. Which color will look here? Some light color will work. This is the volume of the pressure prism, or let me how to find out the volume. This is the volume we are interested in. This is the volume of the pressure prism. This is the volume. So how to write the volume of the pressure prism? That is half into base, that is rho gh, into height, that is h, into b. That is the hydrostatic force. That is how we can calculate the hydrostatic force. Is this clear? And also we can find out the center of pressure. Cp will, or the line of action of this hydrostatic force, the line of action will pass through centroid of the pressure prism. Centroid of pressure prism. The line of action of this force will pass through the centroid of the pressure prism. Can you find out the centroid of the pressure prism? What is the centroid of the triangle? This is the centroid of the triangle. So the line of action of this hydrostatic force will pass, this F will pass through the center of pressure prism, centroid of the pressure prism. And the depth of this centroid is 2h/3. Agreed or not? The pressure prism, centroid of the pressure prism is important. So either use the formula. If you use the formula H is equal to x bar plus Ig by Ax bar, you will get the same result. X bar is, this is the location of G. X bar is this. X bar will be equal to h/2 plus Ig will be equal to bh³ by 12. That is the, this is the rectangular surface, bh³ by 12 into area, that is b into h, into x bar, that is h/2. If you will do the calculation, then you will get 2h/3. Or you can directly find out 2h/3 from the top, from the free surface, that is h, or you can call it as h/3 from the bottom. I hope it is clear. किसी को कोई doubt है? Anybody is having any doubt, or we can proceed further? Can we proceed further? Similarly, for a curved surface, in curved surface, what is the problem is, in plane surface, only the magnitude of pressure was increasing with depth. The direction was same. The direction was not changing. Even if it is inclined, the direction is normal to the surface. The direction was fixed, which is always normal to the surface. But if it is a curved surface, along with the magnitude of the pressure, the direction is also keep on changing. Here the direction of pressure force is horizontal. Here the direction will be like this. Here is like this. Here it is vertical. So the magnitude as well as direction both are changing. That is why we need to resolve these forces into two components. One is horizontal and vertical. And by calculating the horizontal and vertical components separately, we can calculate the total hydrostatic force acting on the curved surface. How to calculate the horizontal component? Try to understand. This is the curved surface, let us say. What we need to do is, we need to take the vertical projection of this curved surface. Whatever is the vertical projection of the curved surface, we will treat the vertical projection as a vertical plane surface and apply all the concepts which we have discussed previously. Either use the formula or calculate the average pressure multiplied by area of the projection, or you can use the pressure prism. That is purely your choice. But for horizontal component, what we need to do is, you need to take the vertical projection of the curved surface and apply the formula to the vertical projection, or use the vertical projection as a vertical plane surface. So this is, let us say, the vertical projection. This is the vertical projection. And the vertical projection is having the location G here. And the depth of G for the vertical projection is X bar. That is what we do. So the horizontal component is density of the fluid into G into the vertical projection area of the curved surface. It is not the area of the curved surface. That is the vertical projection. The area is AVT into X bar. X bar is the depth of centroid of the vertical projection. What is X bar? X bar is the depth of centroid of the vertical projection. It is not the centroid of the curved surface. So that is how we will get the horizontal component. And to find the location of this horizontal component, it will pass through CP for the vertical projection. The line of action will pass, this is the CP, the horizontal component will pass through the CP for the vertical projection. And how to find out CP? CP is calculated by depth of CP is X bar plus Ig by A X bar. Here A is the vertical projection area, X bar is the depth of centroid of the vertical projection from the free surface. That is how we can find out. Or you can use the pressure prism, that is your choice. I hope it is clear. That is how the horizontal component, that is what I have written here. The horizontal component is equal to hydrostatic force on its vertical projection area. Its line of action will pass through CP, center of pressure, for the vertical projection. And how to calculate the vertical component of the hydrostatic force? How to calculate the vertical component? What we need to do is, for vertical component, this is the curved surface, let us say. What we need to do, we extend all the edges. This edge we need to extend up to the free surface. This edge also we need to extend up to the free surface. This edge up to the free surface, and this edge up to the free surface. So if you extend all the edges normally up to free surface like this, then the weight of the fluid which can be contained by this curved surface up to free surface will be the magnitude of this will be giving the magnitude of Fv, the weight of the fluid which can be contained by the curved surface up to free surface. And the vertical component is equal to the weight of the fluid which can be contained. Fv will be weight of this fluid, weight of fluid contained. How to write the weight of fluid contained? Density of the fluid into volume of fluid contained into G. That is the magnitude of Fv, and the direction will be decided by the actual contact of the liquid with the curved surface. Because the liquid is on the top, so direction will be downward. Because the liquid is in contact with the top, the direction of vertical force will be downward, and the line of action of this Fv will pass through the centroid of the corresponding weight. Pass through the centroid of this corresponding weight. The line of action of this Fv will pass through the centroid of the corresponding weight. Is this clear to everyone? And once we get Fh and Fv, we can find out this is Fv, we can find out the resultant force, that is Fh square plus Fe square under root, because horizontal component and vertical component are perpendicular to each. Even if the fluid is on the other side of the curved surface, try to understand. Look, this is the situation. There is no fluid here. The fluid is on the right hand side having the density rho. What you need to do is to calculate the horizontal component. Just take the vertical projection. Once you take the vertical projection, then apply all the formula. Fh will be equal to rho into g into area of the vertical projection into x bar. X bar will be the depth of centroid of the vertical projection from the free surface, that is x bar. You need to calculate x bar carefully, the depth of the centroid of the vertical projection from the free surface. Now, how to calculate Fe? Now try to understand. Fe will be calculated by the same manner. Extend the edges of the curve normally up to free surface. Up to free surface, like this. This is the level of the free surface. Extend edges of the curve normally up to free surface, and the depth is into the plane of the paper. So this volume will decide, or this weight is going to decide the magnitude of Fe. Even though there is no fluid here, but the magnitude will be calculated by imagining that how much fluid the curved surface can contain up to the free surface. Are you getting it? That is the significance of can be contained. What will be the direction Fe? Can you just let me know the direction of Fe? Who will tell me the direction? What will be the direction of Fe? Fe will be equal to rho fluid into G into this volume. Will give you the magnitude. What will be the direction? Can you let me know? I am waiting for your response. Is it upward or downward? Even though we have considered this fluid, for calculating the magnitude, but the actual contact of the liquid is from the bottom of the curve. The actual contact of the liquid is from the bottom. The liquid is from the bottom, in contact from the bottom, and the liquid will always compress the surface. The hydrostatic force is always normal and compressive, and that is why the direction will not be downward, the direction will be upward. Are you getting it? The magnitude will be same as earlier, but it is the direction which is different. In earlier case, if I show you the earlier case, the vertical component is acting in downward direction because the liquid is in contact from the top, and in this case the vertical force is acting in upward direction, and the line of action will definitely pass through centroid of this corresponding weight. Is this clear? कोई बता ही नहीं रहा है. Why you guys are mute spectator? In engineering, the more you involve yourself, the more comfortable you becomes with the concept. That is all about the hydrostatic force. Let us now move to the second part of our discussion. That is the buoyant force, which is extension of this hydrostatic force only. What is the buoyant force? Buoyant force is the net vertical hydrostatic force. The buoyant force. When a body is immersed in a fluid, either completely, there is a completely immersed in the liquid, or partially. When a body is immersed in the fluid, either completely or partially, the net upward hydrostatic force or the pressure force exerted by the fluid on the immersed body is known as buoyant force. The buoyant force is nothing but net vertical hydrostatic force, and the direction is always upward. Whenever the body is there, we need to calculate the upward force and then downward force, and upward force is definitely greater than downward force. So the net will be equal to buoyant force, that is upward force minus downward. That is how we can get the buoyant force. That is the buoyant force. If you are able to calculate the hydrostatic force, vertical component of hydrostatic force, you will be easily calculating the amount of buoyant force on the body, which always acts in upward direction. The buoyant force will always act in upward. Right? And what is the magnitude? How to calculate the magnitude of buoyant force? According to Archimedes principle. Do you know the Archimedes principle? According to Archimedes principle, the buoyant force is equal to weight of the fluid displaced by the immersed body. How to calculate, how to write the buoyant force? Density of the fluid, because it is the weight of the fluid, into volume of the fluid displaced into G. Rho into V is mass into G. That is the amount of buoyant force which always acts in upward direction on the submerged body. It has nothing to do with the density of the body immersed. The buoyant force is not involving the density of the body. What is VFD? We can find out the volume of the fluid displaced. VFD is the volume of the displaced fluid by the immersed body. Do you know the story, Archimedes story? Do you guys know how the Archimedes principle got invented? Eureka. How many of you know the story? Eureka. Archimedes story. Volume of displaced fluid, and rho F is the density of the fluid, G is acceleration due to gravity. It is not connected with the density of the body. कितने लोगों को मालूम है Archimedes story? चलाई? And what is the center of buoyancy? Center of buoyancy is the point of application of buoyant force, and it is the centroid of the displaced fluid. The center of buoyancy will be the centroid of the displaced fluid. Okay, so let me share the gold story. Yes, Bhavya. Let me share it once again. It was interesting story. Once Archimedes was asked to detect the fraud in the golden crown. The king had asked Archimedes to find the fault in the golden crown, whether the golden crown is made up of pure gold or it is having some silver addition into it. So one day when Archimedes was taking the public bath, what he realized is the more his body sink into the bathtub, the more is the water displaced, or the more is the water coming out of the bathtub. So what he concluded was the volume of the water coming out of the bathtub is exactly equal to the volume of his body. So the volume of water coming out is same as is equal to the volume of the is equal to his volume. Then he extended this thing to the golden crown. How? He realized, or he thought that if the gold is heavier than silver, if it is a pure gold, then the same weight will have lesser volume. Same amount of gold or the same mass of the golden crown will occupy lesser volume compared to the gold added with the silver, because the silver is lighter than gold. Silver is having less density. So if the silver is mixed with the gold, then the crown will occupy more volume compared to the pure golden crown. And the volume of the water displaced will be equal to the volume of the body. Then if it is a the pure golden crown will displace less amount of water compared to the mix of gold and this silver, that will displace more water. And that is how he came to the conclusion, or he found out the way to detect the defect in the golden crown, and he kept running naked on the streets crying, Eureka, Eureka, I have found the way, I have found the way. That is how yes, if he would have used the bucket and the mug, then the Archimedes principle could not have been invented. He was having a bath in the bathtub. There the concept of buoyancy came into existence. Now, if the body is immersed in the fluid, then there are two forces acting on the body. When the body is immersed in the fluid, there are two forces which are acting on the body. One is the weight of the body itself, which always acts in downward direction. Another is the buoyant force, which is exerted by the static liquid. There are two forces which are acting. There are two forces which are acting on the immersed body. One is the weight of the body itself, which is acting in downward direction, m into g. Another is the buoyant force, which is acted by the fluid on the immersed body. So if we talk about the equilibrium of the body, one is, if we talk about the vertical equilibrium, then the amount of buoyant force exerted by the static liquid should be equal to weight of the body, so that the net vertical force becomes zero. How to write the buoyant force? That is by using the Archimedes principle, weight of the displaced fluid, density of the fluid into volume of the fluid displaced into g. How to write the weight of the body? That is the density of the body into volume of the body into g. From here, what we can conclude, that is for vertical equilibrium, we can say volume of the displaced fluid can be written as rho b into Vb upon rho f. If the body is in vertical equilibrium, then we can equate buoyant force with the weight of the body and we can find out the unknown. What is rho b here? What is rho b here? Can you just let me know what is rho b? What is rho b? Who will tell me what is rho b? Rho b is actually the average density of the body. It is average which is important. Why? Because the body can be made up of number of materials like gold mixed with silver. So it is the average density which should be taken into consideration for the calculation purpose. It is the average. Don't miss the average. It is having greater significance. If the body is a mixture of number of materials, then we need to take the average density of the body. And the fluid is, rho f is the density of the fluid. Vb is the total volume of the body. Vb is the total volume of the body. We can find out the volume of the fluid displaced by the body, isn't it? If the body is in vertical equilibrium. So if the, look, now there are three possibilities here. If the average density of the body, are you able to see it? If the average density of the body is less than density of the fluid, if the average density of the body is less than density of the fluid, do you agree? If the average density of the body is less than density of the fluid, volume of displaced fluid will be less than volume of total volume of the body. Volume of displaced fluid will be less than total volume of the body. So the body will be called as floating body, or we can call it as partially submerged body. The body will be partially submerged, isn't it? If the average density of the body is less than the density of the fluid in which the body is immersed, then the body will be partially submerged, or the floating body, like a ship. Ship is an example of partially submerged body. If the average density of the body is equal to density of the fluid, and if it is in vertical equilibrium, then the volume of the displaced fluid will be equal to volume of the body. And when it is possible, only when the body is completely immersed, that is called as suspended body, or it is called as neutrally buoyant, or we can call it as completely immersed body, or we can call it as completely immersed. Completely immersed. And if the density of the body is greater than density of the fluid, then there is no equilibrium can be achieved. No equilibrium achieved. If the average density of the body is greater than density of the fluid, the body cannot achieve equilibrium. What will happen in that case? What will happen in that case? In that case, the weight of the body will be always greater than the buoyant force, and the body will sink to the bottom. That is why the body is called as sinking body. So based on the comparison between the density of the body and the density of the fluid in which the body is immersed, we can find out whether the body will be partially submerged or the body is completely submerged, like submarine. Submarine is the example of completely submerged body, or hot air balloon, or the body will sink to the bottom. Is it clear? That is one condition. What is the condition for rotational equilibrium? Net moment on the body must be zero, even though the magnitude of buoyant force is equal to magnitude of weight. Even though the magnitude wise buoyant force and weight are same, but if their line of action are different, then the couple will be developed. There will be rotation in the body. So for the rotational equilibrium, there should not be any moment developed in the body. How it is possible? When the line of action of buoyant force, when the line of action of buoyant force and weight must be same. The line of action of buoyant force and weight must be same. Then there will be no couple developed and the body will be rotationally equilibrium condition. The body will achieve the rotationally equilibrium condition. Is it clear? If we apply the same concept for the body which is completely submerged body, example is submarine or hot air balloon. If the body is satisfying both the condition, sigma f is equal to 0 as well as sigma m is equal to 0. So the body is in complete equilibrium, rotational as well as translation equilibrium. So if the body is in complete equilibrium, then what we try to find out? There are three types of equilibrium possible. One is stable equilibrium, when the body comes back to its original position when there is a disturbance in the body. Another is unstable equilibrium, when the body goes away from the original equilibrium position. And the third one is neutral type of equilibrium, when the body remains in the disturbed position or when the body achieves the equilibrium in the disturbed position. Yes. When are you talking, Varun? Are you talking about when there is a hole in the ship? When there is a hole in the ship, then water enters through the hole into the ship. Water enters into the ship, and when water enters, earlier it was air. Earlier it was air into the ship, so that makes the average density of the ship less than the density of water in which the ship is floating. But if there is a hole in the ship, then water enters into the ship and occupy the space. So because of water, because of higher density of water, the average density of the ship becomes more than the density of water, and that is how it sinks to the bottom. Getting my point, Varun? Is this clear? And that is the same reason for a living person floating on water, but a dead body sinking to the bottom. A dead body always sinks to the bottom, whereas the living person floats. Why? Because our body is having the air inside, and because of air present in our body, the average density of a human body becomes less than the density of water. Once the water enter into our lungs, then the average density of the human body becomes more than the density of water, and that is why it sinks to the bottom. All right. The Susoban, the variation is very small. Yes, we can have, because a body is made up of so many materials. Accordingly, we can, if we are using heavier material, the density will be higher. Average density will be higher. If you are using lighter materials, then the density will be lower. Yes, we can. Is this clear? And if the body is completely submerged, then you should remember the short trick for having the stable equilibrium. Have you understood what is stable equilibrium? When a body is completely submerged, look, when the body is completely submerged and in equilibrium, if we disturb the body, if the body come back to its original position, if the force or a couple is developed which brings the body back to its original position, then it is called as a stable type of equilibrium. If we disturb the body slightly, if the body moves away from its original equilibrium position, like it start rotating, or the force or a couple is developed which moves the body away from its earlier original position, then it is unstable equilibrium. If disturbing the body will develop the equilibrium in the new position, it will remain like this, then the body is in neutral equilibrium, or we can call it as neutrally stable. So you should always remember this short trick, BAG. If this is the situation, if the central buoyancy lies, B is the central buoyancy. If the central buoyancy lying above G, G is the center of gravity. If the center of buoyancy is lying above the center of gravity, then the body will be in stable equilibrium. Then the submerged body will be in stable equilibrium. This is the situation. If the center of buoyancy is lying above center of gravity, then the body will be in stable equilibrium. If the center of buoyancy and center of gravity coincide with each other, then the body will be neutrally stable. If the center of gravity is lying above the center of buoyancy, then the body will be in unstable equilibrium. In case of stable equilibrium, the couple developed is called as restoring couple. Due to disturbance, restoring couple will be developed. In case of unstable and in case of neutrally stable, there is no couple developed. So the body will be in equilibrium in a new position. In case of unstable equilibrium, overturning couple will be developed. And similarly, we can memorize the concept for floating body. Floating body like a ship. If the floating body is in complete equilibrium, net force is equal to 0, net moment is equal to 0, then we can find out whether the body is in stable equilibrium or unstable or neutral. The short trick is MAG. For a floating body, M is the meta center, the point about which the body oscillates. That is called as meta center. Is lying above G. If the meta center is lying above center of gravity, then the body will be in stable equilibrium. Then the floating body will be center of gravity. You can see this is the situation. Meta center is lying above G, then it is stable. If the meta center is lying below G, then it is unstable. And if the meta center B and meta center is coinciding with G, then it is a neutral type of equilibrium. I hope it is clear. For completely submerged body to be in stable equilibrium, BAG. For the floating body to be in stable equilibrium, MAG. Meta center lying above G. That is all for today. I hope it is clear, and do not forget, this is the assignment question, and guys, do not forget to be part of day after tomorrow session, which will be about the numerical from the buoyancy as well as hydrostatic forces. Once you practice the numerical, the things will become more and more clear. You can take the screenshot of this homework question and try to solve this question and bring your answer to my Telegram group, or you can write your answer in the comment box itself after solving it. Is this clear? And the last but not the least, the motivational saying, people begin to become successful the moment they decide to be. The success is actually the sum of small efforts doing repeatedly. So if the moment you decide to become successful, it means you are going in the right direction. Definitely you will succeed. Sooner or later, you will definitely succeed. So with this note, let me take your leave. So on Sunday at 8 p.m., I will see you guys again for the numerical practice session for the same topic which we have discussed today. If anybody is having anything to ask, please do let me know. Otherwise, see you day after tomorrow. Enjoy, take care, have a good night, and stay safe, stay healthy, and spend some quality time with your family members. Enjoy your weekend so that you get charged up for your journey of preparation. All right. With this note, let me take your leave. Thank you, guys. Thank you for being there to be part of this session. Take care and good night.